So when you came to quantum mechanics, could you say a little bit about this world, this field that you were coming into? Because well, still as now, there were these equations that were working really well, but nobody could really agree on what those equations mean for what's actually happening in the world. So would you be able to briefly talk about some of the different ideas that people had for that?
I don't know how many people you're going to hear on your podcast, but I suspect if you get all of the different views expressed, you're going to hear a lot of nonsense. Here's one piece of nonsense: the idea that somehow the equations imply that there are multiple parallel universes all existent at the same time, and that in each one of these universes there's a slight variation of you.
So the essential problem that physicists have, my understanding, is that we can predict a set of probabilities for where a particle, where we'll find a particle when we look, but we can't sort of pin it down beyond that. So what is actually happening? Is there anything there until the point that we look? Or are there different ways of interpreting these equations that there can still be a physical objective reality out there?
That's
Is that right?
excellent. I should let you talk about the other
No,
interpretations
don't.
because I'm beyond jaded.
So one idea, the many worlds that you just mentioned. So this is, it's all out there all along. But the uncertainty just comes from the fact that we don't, the universe is going to split every time that an interaction happens, and we don't know which one we're going to be on.
All the uncertainty comes from the fact that we don't know which branch. So they imagine that the universe is branching constantly, with or without observation, with or without people, with or without dogs, with or without amoebas. There's nothing to do with measurement. Measurement is not a fundamental notion in that version of quantum mechanics, or in that story for quantum mechanics. So in that picture, indeed, the universe is constantly branching into branches, I guess I could say.
So you've
And
got this exponential growth in the
you've got
number
this
of
exponential
realities and
growth
universes.
of these universes that never speak to each other. Now, notice how dull that would be for science fiction. If you just made a bunch of universes and you said, okay, there's one over here, and there's one over there, and there's one over there, and there's never any crosstalk. Well, since that's dull for science fiction, the people who write science fiction stories imagine that you can go from one universe to the other. You can transfer from one to the other and talk to the other people in the other universes. Well, but in the many worlds interpretation of quantum mechanics, that's not the case. The universes are just there. They're just there. They don't do anything with each other. They're just there.
Okay, so you're not a big fan of many worlds. Then there's the sort of a group of interpretations around the idea of pilot waves, these sort of hidden influences that we can't detect, but they are determining where a particle is at all times. So even though we don't know where it is in a particular place. We're just not able to access that information until we make a measurement.
Yeah, something like that. So it at the time it was proposed, I think it was genius. In the 1950s, David Bohm really developed it. He thought of a way to take one of the main equations in quantum mechanics, called Schrodinger's equation, and to turn it into two equations. And when he split it into two pieces, he could identify one piece in the one equation as the trajectory of a particle, and the other piece in the other equation as something like a wave equation. And the idea he had was, the waves tell the particles where to go. So that kind of looked nice on paper, but the difficulty was that his waves didn't live in our regular space. They lived in a highly multi-dimensional space, one for each particle. So there was that. And there was also, if we looked at the effects in our regular space, his equations would imply that my doing something right here instantaneously influences you where you are, even before my voice got to you, even before a light ray could get to you. So all of a sudden we have a picture of the universe where its farthest parts are connected to this part right here, right now. And for instance, if you think, oh, Chris might answer a question that I posed to him with a yes or a no. And when I ask that question, being a journalist, I think he's going to reveal what's in his head as the answer, yes or no. Well, in fact, in the Bohmian picture of the universe, my answer, yes or no, doesn't just depend upon what's localized in me. It depends upon things that are happening at faraway quasars right now. So the whole universe is deeply connected.
So we've
People of
got
a mystical bent are kind of attracted to that. By the way,
mhm.
you can see human emotions in every in those people attracted to the different interpretations. You can sort of see their worldviews coming to life. So if you're of a mystical bent and you want to think the universe is one, it is just one, and everything there's not parts to it. There's one. Well, then they're attracted to Bohmian mechanics. There's a great story about Einstein that when he was having an affair with one woman or another, he would, oh, I'm going to get this story wrong. Einstein went through phases, very fatalistic phases of, well, we really have no control over what we're doing. We're just following the flow that physics has specified for us. If your temperament is that you don't want to be blamed for any of your dalliances, then you might say, oh, I like that kind of world. It takes all of the responsibility.
So I like that. We can read people's personalities in the quantum mechanics interpretation and the physics
Yeah,
that
yeah,
they
and you can see
are attracted to.
cowboy in mine that that the universe is somewhat lawless and and that we can assert ourselves over it.
What a lot of these interpretations are essentially doing is they're trying to rescue or maintain the idea that there's a physical world out there, regardless of what we're doing, regardless of the measurements we're making, regardless of what we're looking at. And it's possible to do that, but you need to come up with a landscape that's very, very different to what we might think the world was like. We need to have huge numbers of universes bursting into existence all the time, or we need to have these guiding waves that are in some kind of different kind of space, and even distant parts of the universe are connected. So we can do it, but there's quite a big price to
That's
pay.
right.